Okay, here we have a question from November 2018. Question 3, it's a question on Newton's laws and forces. So it says a box with a mass of 45 kilograms is pulled with a force of 90 newtons at an angle of 50 degrees to the horizontal. The box moves at a constant velocity. The moment we see constant velocity, we know that my acceleration is going to be 0 and that there is no net force on the box. Yes, there's a force on the box, but it's not a net force. Then it says state Newton's first law of motion in words. In the memo it says the force that opposes the motion of a moving object relative to a surface. But if you look in the exam guidelines, it says frictional force is the force that opposes the motion of an object and which acts parallel to the surface. So this is the better definition because it's stating exactly how relative to the surface it works. Then it says to you state Newton's first law of motion in words. This is a body will remain in its state of rest or motion at a constant velocity unless a non-zero resultant or net force acts on it. This is the law of inertia. Okay, so now this box is moving at a constant velocity, so it is actually in equilibrium. So now it says to you, calculate the magnitude of the horizontal component of the applied force. So in order to do this, we have to look and see, here is our applied force. It is 90 newtons, and it is acting at an angle of 50 degrees to the horizontal. Okay, so the horizontal component of the applied force, this is the force that we will call Fx, and it is here horizontally. Okay, so we can split this force at an angle into two forces perpendicular to each other, Fx and Fy. And if you look at my triangle here, the 90 is the hypotenuse, Fy is opposite, and Fx is adjacent. So from this triangle of forces, if we want to find the horizontal component of the applied force, Fx is going to be F, the hypotenuse, times the cos of the angle, which is 50 degrees. So this is 90 cos 50 because F is 90 newtons. So if you put this in your calculator and you work it out, you should get 57,85 newtons. Okay, so now it says to you, calculate the magnitude of the normal force. Now you can see this is 4 marks, so it's not going to be as easy as just finding the horizontal component of the applied force. So if we want to calculate the magnitude of the normal force, we actually need to draw a free body diagram for this object. So here's the block. The first force we're going to put in is the weight acting downwards, Fg. Then the object is on a surface, so we have the normal force acting upwards. This is the force we're trying to find. Then this box has got the applied force over here, 90 newtons, and then there must be friction on this box, and the friction will be acting in that direction, Fk. Now this is very nice, but my forces are not in a straight line, so I need to put my forces in a straight line so I can add them. So you're not supposed to put your components and the actual forces on the same diagram, but I'm doing it here because of space reasons. So here is my Fax, and here is my Fay. Maybe we can rub out the applied force and just leave its components here. Okay, so now we've got a force diagram with all of my forces shown in straight lines by splitting the applied force into its two components. So we want to find the normal force. Okay, the normal force is acting vertically. So if we look at this object vertically, it is in equilibrium. Okay, so if the object is vertically in equilibrium, the forces up equal the forces down. Okay, remember a force is a vector. It has a magnitude and direction. So you can frame this in terms of Newton's second law by saying F net equals ma. The box is in equilibrium, so my acceleration is 0. And then here we must state a direction. I'm going to say up is positive. So my normal force is going up, it's positive. My applied force's y component is going up, it is positive. And my weight, Fg, is going downwards. And all of these together will equal to 0. So if we come back here to look at our triangle over here, the y component of the force is the opposite part of the triangle. So it's going to be, we don't know anything about the normal, but if we want to substitute for FAY, the force FA is 90, and the part of it that is going upwards, the y component, we find by the sine of the angle, because remember over here it's the opposite, so it's the sine of the angle, minus Fg. So Fg is the code name for the weight, and weight is mass times the acceleration due to gravity. So there we get all of our forces in the vertical plane are equal to 0. Okay, so this goes in plus, if you put it in your calculator, you get something like 68,94, and this is 441 equals 0, and then by the power invested in you by algebra, you should get the normal force is 372,06 newtons. And it says the magnitude, so we don't need to say that it's straight upwards, but remember all vectors have a magnitude and a direction. Now it says to you, calculate the coefficient of kinetic friction. Remember, there's two things with friction. There's the force of friction and the coefficient of friction. So we are looking for mu k. And if you look on your formula sheet, mu k equals Fkn. The coefficient of kinetic friction, mu, equals the force of kinetic friction multiplied by the normal force. So if we know the normal force and we know the force of friction, we can calculate mu. Okay, so let's have a look here. Let's have a look horizontally on this object. And horizontally, this object is also in equilibrium because of this constant velocity thing. So if I say to the right is positive, because we always have to state our sign convention, we can say F net equals ma. So there is no acceleration, so my force Fax minus my force of kinetic friction. Can you see in the diagram here? These are my only two forces in the horizontal plane, and they are going to add up to 0 because the box is moving at a constant velocity. So this means my x component, sorry, excuse that very bad f, let's make that f a bit better. My x component is going to be equal to the force of kinetic friction. And I worked out my x component earlier. My x component was 57,85. So the force of kinetic friction is going to be 57,85 newtons. Okay, so but that's not what they asked for. They asked for the coefficient of kinetic friction. So this formula here, I wrote this formula wrong. That's terrible. Okay, so the coefficient of kinetic friction, mu k, equals the force of kinetic, the ratio of the force of kinetic friction. Did I write it wrong? I need to get my data sheet out and check. Just hold on with me 1 second while I get my data sheet out. Okay, no, I'm right. Fk, the force of kinetic friction, equals mu k n. Okay, so the force of kinetic friction, which we just worked out here, is the same as the x component of the applied force, is 57,85 times mu, and remember we worked out the normal over here. So this is 372,06. Okay, so to work out the coefficient of kinetic friction, it's the force of friction over the normal force, and if you put that into your calculator, you get 0,155 something. So I'm going to round this off to 0,16. Now remember, the coefficient of kinetic friction, it is a ratio of two forces, so it has no units. You just leave it like it is, 0,16. Remember also, if you get an answer bigger than 1, you've done something wrong, because the coefficient of kinetic friction is nearly always a small a fraction, okay, which we write as a decimal fraction, obviously. Now the last part of the question says, will the coefficient, they're not asking you about the force of friction, they're asking you about the coefficient of friction. Will the coefficient of kinetic friction change if the angle of the applied force is decreased? So they mean, what happens if we put the force in here lower, like that, or perhaps like that, okay? What will happen to the coefficient of kinetic friction? Now, the short story is the absolute value of the friction will change, because by changing this applied force, we change the normal force. But the coefficient of friction depends only on the nature of surfaces in contact. So no, the coefficient of kinetic friction will not change, because it depends on the nature of surfaces in contact. So unless you suddenly put sandpaper on the boxes or something, okay, it's not going to change the coefficient of kinetic friction, or you change the table surface or something like that. So that's the only way to change the coefficient of kinetic friction, which is different from the value of friction.